Welcome to this exercise where I want to talk about how to simplify expressions with logarithms or exponential functions. So therefore we have here two partial exercises, A and B. The first expression to simplify is natural logarithm of 1 divided by exponential function of 1 divided by x. The second one is exponential function of 2 minus natural logarithm of 1 plus exponential function of x. So let's take a look at the first one. Here we see we apply a logarithm on a fraction. Whenever we have something like this, we can use the rule for the logarithm, as in logarithm of a divided by b is the same as logarithm of a minus logarithm of b. So here we would have logarithm of 1 minus logarithm of the denominator. Well, logarithm of 1 is 0, so this simplifies to this expression. Well, I could have written the 0 in front of the minus, but well, we don't need it. So if I have this expression here, I can now take a look at this part where the natural logarithm is applied on the exponential function. Since they're both inverse functions, they cancel each other out, and all of this simplifies to minus 1 divided by x. Well, that's more or less everything I could do. Well, if I wanted to, I could write 1 divided by x also as x to the power of minus 1. Then I would have minus x to the power of minus 1. But that would be everything I could do in this context. So let's go to part B. In part B, I have this expression. And here the first problem is that I apply the exponential function on these two parts with a minus in between. Well, there's one rule for working with exponents. That is, if I have x to the power of a plus b, I could also write this as x to the power of a times x to the power of b. So here I could do the same, exponential function of 2 times exponential function of minus logarithm. Well, I do this slightly differently because if I have a minus in the exponent, I could directly put this below a fraction line. So this minus transports this exponential expression below the fraction line. So it's like exponential function, or x to the power of a minus b is the same as x to the power of a divided by x to the power of b. Well, I did this here. Then I can take a closer look at the denominator. Again, similar to what I had in A, exponential function applied to the natural logarithm. Once those two are next to each other, they cancel each other out, or applied one on the other. They cancel each other out. And I'm left with this expression. And at this point, I cannot simplify any further because, well, I could write exponential function of 2 as e to the power of 2, or I could calculate the value, but this wouldn't make this expression any simpler as is. So, well, that's about it on this part, on the whole exercise. So I say goodbye and see you next time.